Talking about gas laws and how to apply these laws to the different story problems. Gas laws describe the relationship between the factors of gases. So we can describe initial and final conditions of pressure, volume, temperature, and the number of moles. You want to make sure that your units cancel out, so you want to make sure that your units are the same on both sides of the equation. You also want to make sure that temperature has to be in the units of Kelvin before you plug into the formula. And there are a few gas constants. The units of pressure will tell you which gas constant to use. For example, if you are dealing with pressure in atmosphere, then this is the gas constant you want to use. And if you're dealing with pressure in millimeters of mercury, this is the gas constant you want to use. Let's take a look at the first example. A 2-liter container of nitrogen gas has a pressure of 3.2 atmosphere. What volume would be necessary to decrease the pressure to 1 atmosphere? Let's start off with our given table. So my first volume is 2.0 liters. My first pressure is 3.2 atmosphere. And then it's asking what volume, so that is my second volume, would be necessary to decrease the pressure to 1.0 atmosphere. So my units of pressure are the same on both sides of the equation. That's good. So let me try to find a law that relates pressure to volume. And that law is Boyle's law. So we're going to write down the formula and then plug in our numbers. We're going to solve for our second volume. So our V2 is equal to 6.4 liters. Let's take a look at another example. Oxygen gas is at a temperature of 40 degrees Celsius when it occupies a volume of 2.3 liters. What temperature should it be raised to occupy a volume of 6,500 milliliters? Let's go ahead and write down our given table. They start off by giving us the temperature and the volume. And they want us to solve for the second temperature. And they give us a new volume. So let's take a look at this. Our temperature is in Celsius. It must be in Kelvin. So 40 plus 273 gives us 313 Kelvin. And then let's take a look at our volume. Our volume 1 is in liters and volume 2 is in milliliters. We're going to have to convert milliliters to liters. So let's go ahead and set up that conversion. If milliliters is in the numerators, milliliters is in the denominators. 1 milliliter equals 10 to the negative 3 liters. So our new volume is 6.5 liters. All right, so we have volume in the correct units, we have temperature in the correct units. The law that relates volume to temperature is Charles's law. So we're going to go ahead and plug that into our formula. And our V2 is 6.5. We're going to solve for T2. And when we plug that into the calculator, we get something like this. Our final answer has to be in the correct sig figs. If I take a look at my given information, the fewest sig figs is going to be 2 sig figs. So I have to round this number to show only 2 sig figs. And when it comes to temperature, you can't put temperature in scientific notation. So you're going to have to write 880 Kelvin. Final answer. Remember that zero, that trailing zero doesn't count because there is no decimal in the number. So this 880, the way it's written, has only 2 sig figs. Let's take a look at another example. An unknown quantity of gas in a container has a pressure of 1.2 atmosphere, a volume of 31 liters, and a temperature of 87 degrees Celsius. How many moles of gas are in the container? As always, we're going to start off with our given, and they're giving us pressure. They're giving us volume. They're giving us temperature. Temperature is in Celsius. I'm going to add 273 to that, and I'm going to get 360 Kelvin. And it's asking for the number of moles. And because I'm dealing with pressure, volume, temperature, and the number of moles, I'm going to go ahead and write down my R. Because pressure is in atmosphere, I'm going to use this R. All right, so the formula or the law that relates pressure, volume, temperature, and the number of moles is called the ideal gas law. PV equals nRT. I'm going to go ahead and plug in my numbers. So N equals to 1.3 moles. Final answer. Let's take a look at another example. What volume of hydrogen at 26 degrees Celsius and 723 torr may be prepared by the reaction of 8.8 grams of gallium with an excess of hydrochloric acid? As always, I'm going to write down my given information. And they're asking for the volume of hydrogen. So I'm going to put a little hydrogen in there just to remind me that we're talking about hydrogen. And they give us the pressure, 723 torr. But I'm going to go ahead and convert that to atmosphere so I can use one of my gas constants. And they give us temperature, and that equals to 299 Kelvin. And they don't give us N, but they give us the mass of Ga, 8.88 grams Ga. So they're asking us about hydrogen, but they're giving us information about Ga. So we have to do a conversion to figure out the moles of hydrogen so that we can use this gas constant, this formula. So let's go ahead and do that. Grams of Ga is in the denominator. I get that number from the periodic table. Moles of Ga in the denominator. And there's a relationship in the balanced equation. For every 2 moles of Ga, there are 3 moles of hydrogen. So I can go ahead and put that into my conversion. So what happens is grams cancels out with grams, moles cancels out with moles, and I'm left with moles of H2. So this will give me 0.191 moles of H2, and we can call that N. Okay, so we have the P, we have the T, we have the N, we also have the R. Now we can go ahead and plug that into the ideal gas law. PV equals nRT. I'm going to use N, so the number of moles of hydrogen. My T. Solve for my V. V equals 4.93 liters. So this one requires the gas laws and stoichiometry. We need a balanced chemical equation to do a switcheroo, to go from Ga to moles of H2. Good luck and keep practicing.